We are the team that designed satellite project. We're going to use API authentication encryption to do our project.
As you can see, we have our compilation code displayed on the screen right now, which we can go ahead and enter in. And from here, we can then run our code, which will prompt you for a United States zip code. If you enter something that is not a zip code, it will then again ask you to actually enter one. So for example, we can enter the one for Boston, or one of the ones for Boston being 02215. And this is the response that we get from our program. So this is a simulated version of what our project was supposed to be, being the communication between two boards, the encryption of a zip code being sent to a second board, which gets a response from the OpenWeather API and then returns it to the first board. So as you can see, we have our private key as well as our initialization vector. As in the plain text entered is 02215. Here's our outputted ciphertext. As it's transferred to our second board, it decrypts it back into what it is supposed to be, gets the API response, and can extract from the JSON that the current temperature in Boston is 11 degrees Celsius or 52 degrees Fahrenheit, and the current weather is clouds or cloudy. It then can take this, form a ciphertext based on the key and initialization vector provided, and then transfer it to the first board and decrypt it. So this is an example for Boston. What you can also do is, for example, I'm right now at home in Nashville, Tennessee. So if I were to run this and enter the zip code for Nashville, you could get 37202. And as you can see in the output, the current temperature in Nashville is 67 degrees Fahrenheit, and it's raining. Something to note is that the key and the initialization vector are actually different between, you can see the initialization vector here. If I stretch this a little bit more, you can see that between the two, it changes from each iteration that you run the code.
Authentication use RSA key pair generation for B1 and B2. B1, B2 generate the key pairs and send the public key to each other, and then B2 encrypts B2's password secure ID using B1's public key. B2 sends the encrypted password and secure ID to B1, and B1 decrypts B2's password. B1 decrypts B2's secure ID using B2's password and authenticate the B2's identity through this secure ID. Now, B2 need to authenticate B1 as well from steps 3 to 7, and then the authentication process is completed. Now let's illustrate in the command line. First, B1 is going to generate a pair of key pairs, and then write out the B1 key pair, and then show the B1, B2 directories, and B2 key pair and password generation. Then we will be able to make B1 secure ID plain text, and then we will be able to generate the secure ID ciphertext. And then we'll be able to show the secure ID ciphertext in Vim. And then we can generate the B1 password ciphertext in binary and then base 64 output. And then we show the B1 password ciphertext binary output in Vim and show the B1 password ciphertext base 64 output in Vim. And now we change the file names in B1 directories and move out to B2 for decryption. Now we convert B1 password from base 64 to binary output in B2 directory. Now B2 get B1's password plain text in Vim, and B2 decrypts B1's password ciphertext and get the B1 password, which is displayed in the previous text. Now B2 get B1 secure ID in Vim, and the B2 decrypts B1's encrypted message with B1's password, which is shown previously too. And B1, B2 directories files are shown here after B2 obtained B1's password and secure ID. And now we generate the encrypted secure ID and password in B2. This is a screenshot of the generation process, and this is the B2 password in Vim, and this is B2 secure ID in Vim. This is B1, B2 directories files shown after two-sided authentication, and this is B1 secure ID in them and B1's password